Ah! What is wrong with you, Derek? What is wrong with you? All of scientists, don't you know how to read? Do you know how to read and analyze at all ever? Euclid's fifth postulate is normal! It's normal! It's not even Euclidean geometry stuff. It's not weird. It's not spherical. It's not this hyperbolic. It's flat and normal. Oh my God, did you read it? Let me read it. Let me have him read it for you again. You are on self. You can read this for me again.
And the fourth is that all right angles are equal to each other.
But postulate 5 gets the big guns.
Which is that if a straight line falling on two straight lines makes the interior angles on the same side less than...
Look at what is happening here. Pretend that these two lines are two rails on a train track, okay? And pretend that the world is flat. Pretend! Pretend it's flat! Just pretend. For 2 freaking seconds in your life, pretend that the world is flat. Now look at these lines. We got a 93 degrees. We got 85 degrees. 93 is wrong. 93 is wrong. You can't have that. But forget about it. The point is, if the total is less than 180, meaning straight dudes, right? But they're not straight. They're off by a little bit. In other words, if your straws are not exactly parallel, if you were to make those direct lines go to a very indefinite point, eventually they meet each other. This is a flat geometry situation. I'm Euclid, come back from the grave to tell you it's not hyperbolic, it's not spherical, it's flat, what he's talking about. It's normal. You want to look at some flat lines? I'll show you some flat lines. These are flat. These lines here are flat. These two lines, these bars that are the thing that is holding up my goddamn everything, they're flat and they are parallel. They are beautifully parallel. They never stop being parallel no matter where I move the bar. These two, this one up here, this one down here, they are exactly the same length from each other no matter what all the time. They're flat. They get closer to each other, but they are still flat. Compared to each other, they are flat. They are both, if you were to draw a line this way, both of them equals 180 degrees. There's 90 here, there's 90 there. Flat line, boom, you got it. So what is Euclid talking about? They're not flat. They're not going straight. They're going like this. In other words, he's describing an extremely big, basic-ass triangle. There is no hyperbolic, there is no spherical about it. It's just straight lines. They were less when they started, they're going to be less when they join. That's what it says.
Two right angles. The two straight line
5 gets the big guns.
which is that if a straight line falling on two straight lines makes the interior angles on the same side less than two right angles, the two straight lines, if produced indefinitely, meet on that side on which of the angles less than the two right angles.
What the hell is he talking about?
He's talking about a goddamn basic-ass triangle, and that's all he's talking about. It doesn't even have to be like 85 degrees. Any amount. If you're talking about 90 versus 89.9999999, it will eventually meet. They will meet each other. That's it. That's all he said. That's all Euclid said. He didn't say anything else. The words verbatim is it will just meet at some point eventually. These 2 points are not flat, right? You got flat here, right? This looks flat. This not flat. This flat. This not flat. This flat. This not flat. Eventually, if you spread it out far enough away, this will become this. Okay, that's how that works. It's a triangle. You're stupid. You and your friend are stupid. The entire scientific community is stupid because they think that he was talking about hyperbolics or something. Oh, it needs to be thrown out. He's just saying a triangle. He explained wobbly lines, he explained flat lines, and he explained triangles. That's all he freaking did. But that's not all you get wrong. That's not all. You have a couple more mistakes. You talk about how space-time is curved. It's not! Space-time doesn't curve around objects. No, it doesn't. No, it doesn't. You want to know what actually happens? I have to explain this to you. When you're talking, you're farther along in the video. He talks about how a space-time, right, because of whatever else in the explosion, and there's a galaxy between it, this happens.
This is life science research.
Shut the fuck up, commercial. Okay, so you imagine, they imagined that a supernova, it was refracted off of these other galaxies, and you're saying, well, space-time curved that light. Space-time doesn't curve shit. Space-time's flat! Everywhere! You know what does curve shit? Atmosphere! Atmosphere. An atmosphere, or just water, going through any medium is what makes light curve, like a prism. Galaxies are nothing but a gigantic medium of gas. And guess what? Light's gonna curve through the atmosphere of a galaxy. There is no space-time curvature there. There's just atmosphere. And the different amounts of densities or whatever else with the galaxies and how that works is what makes the light bend at different rates and whatever else. So a year later, they saw that same explosion happen again.
Curved geometries of Bolyai and Riemann. But so far, all the effects we've looked at are local distortions of spacetime.
No, you're not looking at distortions of space-time. Just like time doesn't dilate when you go away from a gravity well, it just changes your clocks. Get it right? Light bends in an atmosphere. This is not why I've been having a headache for all day. This is only why I've been having a headache for the last 2 hours. Or why it's gotten worse. I don't know why I had a headache back when I woke up at 4 p.m. I've been awake for a long time. That's not changing I would say the same things yesterday at any given time of day. I have said this before, I'll say it again. The atmosphere. If there's atmosphere in a galaxy, yeah, there's gas all over the freaking nebula. You know it is, because it's freaking opaque as frick. There's stuff there, you can't see past it unless you're really looking, and then it starts to thin out a bit, but there's still stuff there. And the stuff near the edge of the circle, which is, or the sphere, which is planet or whatever, the sun, that light bends around that atmosphere. It's not space-time. And you mention it again. The people on a goddamn flat trajectory of the guy who's falling is like, where is that part that you mentioned? Oh, and in a sphere, he's you talked about the dude measuring the triangle of and the circumference of the universe. He wasn't measuring the circumference of the universe. He was measuring the circumference of the planet. He was only looking at the area of the planet. He was only looking at a certain small area of the planet, so he couldn't actually, with any decent approximation, be able to notice the curvature of the Earth. But you could infer a tiny bit if you looked far enough away. But like, it's hard to just do that, because the farther you look, then things just tend to dip away. It's obvious to anyone who notices it. But then, like, you mentioned something about, what the hell did you mention this thing about? There it is. Oh, look at this bullshit he talks about. Veritasium, you're full of shit.
The answer is because the space-time that straight line is on is curved.
No, it's because the curve, the orbit, fucking look at this shit. The orbit around the planet is so damn big. The curve, the turning that you're doing is basically unnoticeable. You can't tell that it's happening. What kinds, if you were to look at the direction that you're going, all right, around the planet, you basically only feel yourself maybe pulling to the right a very fraction, tiny little bit. It doesn't matter. It's not proof of the curvature of freaking space-time. That's not what's happening. You go in a circle, it's just the circle is so big, it seems flat. It seems that you're not even going anywhere different than a straight line, but you're actually going a curved line. It's such a big circle, it seems like it's straight. It's a straight segment of that circle. It's just a very huge circle.
See, massive objects curve spacetime.
No, they don't.
And objects moving through curved spacetime will follow the shortest path through that curved geometry.
What is happening with gravity? As a planet or a star, whatever, is moving through the galaxy, it itself, all of those things, are all constantly in that freaky spiral thing motion that was talked about. The motion does not look like they're going down a constantly closing drain. It looks downright like a tube or that's why, that's also, it moves like an ellipse, right? You go sometimes above, as the sun is moving, right, forward in a big circle around the galaxy, the planet moving around the sun sometimes move ahead of the sun, which is what it does in January, I'm guessing, and sometimes farther back, which is what it does when it lags behind in July. Well, you wouldn't be ahead of the sun further in July. I'm guessing that July is the tail end, right? Then you pull up closer to the sun as you're moving along with its, or in its own direction of orbit around the galaxy's core. And ironically, we're not even going a straight line around the galaxy core. Proper orbits have this wobble thing going on with the galaxy. It's like, what? It's all wobbly. It's all wobbly when you're going around the whole galaxy core. There's a sinusoidal type of wave going on when it comes to the sun and the entire thing of the solar system going through around the galaxy. So, okay, if space-time doesn't curve, what's happening with gravity? It's called buoyancy. What happens with everything is that a certain amount of electromagnetic field is being pulled in to massive objects. Electromagnetic field is being pulled in. Kind of. Objects themselves are pushed away as they are flung out, but the electromagnetic field is all pulling in, right? But objects are also, lighter objects are all pulling in. You realize as an object is going through space, everything is pushing towards the center of that free moving object. You are splattered against the planet at a rate that doesn't totally crush you. So what happens is also it's turning. So the amount of force you feel is against an edge of the planet. But the curve of that edge is so massive and big that you don't notice it any different than just flat down on the planet. But it's actually slightly, there's a slight curve to that gravity. There's a slight curve to its, because its rotation and moving forward as it goes through space. That's what's happening. And the heavier stuff falls in, and the lighter stuff is all pushed away by the heavier stuff, technically ends up being floating up into the atmosphere. The lighter stuff is able to overcome, basically, the movement of a planet moving through a solar system, moving through a galaxy. Gas is able to rise, which is insane. That this tiny particle of gas is so energetic, it actually ejects itself up into the upper atmosphere, where it then becomes colder, slower, falls back down. It's no longer bouncing off of everything enough that it goes and becomes a goddamn freaking cloud. condenses more, turns into rain, sleet, snow, whatever, hail, all that jizz, and lightning. The energy form of that. So there is no, there's there's no bending of space time. There is no dilation of time. None of that. And Euclid wasn't talking, most importantly, Euclid was not talking about hyperbolic space. He wasn't talking about a saddle at all. He was just talking about two lines that are not totally going straight in the same direction. They're going slightly towards each other. Eventually they'll meet. Wow. Big brainwave that no one understood for 2,000 years, and you still say it wrong. Because, like, something, it only works for Euclid on hyperbolic freaking saddles space. And according to the measurements that we did, it says all of space generally is flat, which is weird because when you think of stuff like the Great Attractor, which is a gigantic gravitational well and stream that we are in, we're like way up here. The gravity thing is down here, and we're like on a stream heading towards it. It's big. If you think of the galaxy, we are like the galaxy is like a grain of sand compared to the entirety of the gigantic stream that we are a part of, all flowing towards this colossal Great Attractor, right? The size of God knows what. And yeah, we're all pulling in, and it's all this eddy current of all the stuff all flowing in because all the rest of the stuff is also flowing in. The energy off of this Great Attractor flows not only, it flows more easily when around other objects that also move energy around, which is what massive objects do. They move electromagnetic fields around. So it's most of why you have gravity. It's a lot of why you have gravity. The buoyancy force. The buoyancy force is so huge. The area of the sun, we are inside the sun. We are inside the atmosphere, which is the empty space of the bubble. Once you get outside of that, it becomes nebulous space. Crazy. You sent Hubble out, you sent the Voyager out there. Once it gone outside of this bubble that is past Pluto, past that asteroid belt, the second asteroid belt, into the interstellar space, it's freaking gaseous out there. And that's what we're moving through. We are moving through a nebula. But the sun has such amazing solar winds from it that we are actually moving. Our planet is basically inside of that empty space. It's interesting to know that everything is being pulled around by the sun, and yet there's this area that is beyond the sun's reach when it comes to everything pulling in. It's ironically the same amount of space as the area of its pushing out. So you could say we are actually really far in to the atmosphere of the sun. It's just that parts per million, nothing. But it's still the area of the sun. The area of influence of the sun reaches all the way out into past Pluto. That's how that works. So it's interesting that the area of the sun is also mostly a sphere once you get outside of everything. It's like, wow, if space-time is curved, it looks pretty much spherical. What influence area? Meaning the magnet is pulling from all directions at the same time. It's not this. It's not like that. The area of effect and the way it works. But you gotta think, that's when you think of a flat plane. When you actually put that in all directions, it's a sphere of influence. But everyone's like, oh, it has to be like this. It's like, no, it doesn't even work like that. It's one way to visualize it. It's one way to calculate it, perhaps. It's not a way it actually operates. And if you were to visualize it in a proper three-dimensional frame of reference, this is inaccurate AF. This is not how that works. How it warps space-time. You're talking about an object that has an influence in three-dimensional space. There is no weird dip going down there. There's none of this happening. It doesn't look like that. It doesn't work like that. It can't. The area and the pull-in from the star is so massive. And it has to be the electromagnetic field, which everyone says it's too small to have an effect. The electromagnetic field of the planet might seem weak and basic and simple, but when we're talking about the area of the whole solar system, the electromagnetic field is literally everywhere. Literally everywhere. No matter where you are in this solar system, you run a generator. What you're doing is you're exciting the electrons, right? And also the electromagnetic stuff is being affected. Just the fact that light is everywhere means you know the electromagnetic field is everywhere. You don't even have to think of anything else. Light is doing that. Light is the electromagnetic field doing wavy things. So if we understand the fact that the electromagnetic field is everywhere, encompasses everything, flows through everything, is attracted to anything of object, anything of mass. It's not hard to understand how it works. It's not this.
So while astronauts in the space station are following a straight line, it appears curved to a distant observer because the Earth curves the space-time around it.
No! No, you're stupid! Shut the fuck up. That is not the Earth space-time. It doesn't even look to them like they're going in a straight line. It doesn't feel to them like they're going into a straight line. Relative to the curvature of their direction of motion, yeah, them on this small segment, if you were to look in 1 mile forward and backward, it basically looks like a straight line, their direction of motion, because it's such a big area that they are turning in. that their curve looks straight. Because you've zoomed in so close to the edge of the circle, it looks like this. It doesn't look like this. It looks like this. Right? The plate is so big, you're like an ant on the plate. That's how big the area of the circle is. With the saying, you're upsetting when you say stupid stuff like this, Derek. Genuinely pissed off at you. But it's not just you. The problem is it's not even just you. We're talking about NASA here is stupid too. Disrespect to all NASA who dares think that this is what's really happening because you're stupid. It's not. How can you get away with saying this stuff and pretend to be a real scientist and science communicator? I don't understand how you can do it.
So the behavior of straight lines in curved geometries is core to understanding the universe we live in. And in the more than 100 years since it was published, the general theory of relativity has been remarkably successful. In 2014, astronomers briefly observed a supernova, a violent and extremely bright death of a star. In fact, they saw the exact same supernova in 4 different places.
Yeah. That's because there was a galaxy in between it. The stuff in that galaxy refracted the light, as stuff tends to do. Matter tends to do that. And therefore you see 4 distinct supernovae. If you do the math, you connect all those points, you can find out that it must be some central point behind the black hole, behind the galaxy, where these 4 dots were noticed. And so that's why if you actually look at if another galaxy is closer, and it's also warping the way that the light is pathing because of the atmosphere of the galaxy. Yeah, they predicted it would happen a year later, and
How? Well, in between the supernova and Earth, there was a massive galaxy which curved spacetime. So light from the supernova...
it curved the path of the light. Space-time has nothing to do... Shut up.
...spreading out in all directions, had several different paths to reach the Earth. And 4 of those reached Earth at approximately the same time. The galaxy had functioned as a massive gravitational lens.
As a massive atmospheric lens. Get it right, you dingus. Atmospheric lens. Same as if you put light into water, it's going to bend. Same as if you put it through a prism, it's going to bend. Or an atmosphere. It's not gravitational lensing. It's atmospheric lensing. There is a difference. You can call it the electromagnetic attraction of the black hole lensing, but it's not. What do you say?
Had several different paths to reach the Earth, and 4 of those reached Earth at approximately the same time. The galaxy had functioned as a massive gravitational lens.
Yeah, you can say gravitational lens. It's not space-time that's curving. Like, you have to know the electromagnetic spectrum is everywhere. That's why light is able to pass through all of space-time, get to us. It's propagating on the area of space-time. But then you have gravitational waves, and we talk about that later, where he talks about galaxies colliding, which is neat and all that shit. That's pretty cool. How galaxies collide and stuff. Where the fuck does he talk about that? I don't know. Somewhere he talks about galaxies collide. There it is.
They saw the same supernova once more.
Yeah. Whatever. Looking for the part where he talks about gravity. When does he talk about freaking the ripples of freaking...
Of curved spacetime, we can now even measure the ripples of spacetime itself. Gravitational waves formed by cosmic events far, far away, like the merger of black holes. And according to a recent survey by Nanograv, the fabric of spacetime seems to be buzzing with the remnants of grand cosmic events.
Yeah, like... The electromagnetic attraction of everything. Literally, if you have just two pieces of copper moving, or copper and another metal moving, the electrons move and stuff like that. The electromagnetic field is a bubble that goes far beyond any magnet. The electromagnetic influence from these black holes as they merge and it becomes uniform. It's this big ringing that's happening. It's like, so the thing you have to take from all this, one, there's no such thing as a time dilation. Two, space-time does not curve. Light curves in an atmosphere. And through maybe the way that electromagnetic fields are affected by gravity objects. Electromagnetic fields is not space-time. It's electromagnetic fields. There's a difference. You understand? It's not space-time. Totally different thing. It's an object placed on space-time. We say this, but we cannot keep saying this because just manipulating the electromagnetic fields and the influence of them isn't enough to prove that you're manipulating space-time. There's a whole other freaking thing happening if you're actually manipulating space-time. I need a drink.
100 years since general relativity was published, countless findings have supported its predictions, and at its very core are the curved geometries of Bolyai and Riemann. But so far, all the effects we've looked at are local distortions of spacetime. What is the shape of the entire universe?
Well, and long story short, he says it's flat. It seems virtually flat. And do you know why that is? Do you know why that freaking simply is? It's ridiculous to say, oh, but here's the thing that he says that's absolutely so upsetting. The most upsetting.
In fact, observational error. But that shouldn't be very surprising. Take this balloon, for example, which approximate angle will add up. Angles in the there is no solid. In order to overcome the scale issue that away is this background, or CM, there are some raw, which were then information we have of power spectrum shows. Essentially a histogram of how often came as we'd expect, larger than predicted, and this peak would shift to the right flat. So that's basically zero within the margin of error. So we're fairly certain that the universe we live in is flat. To
Keep cool under pressure. I need a clear mind. Gillette.
Shut up.
Seems to be remarkably serendipitous. Right now, the average mass energy density comes down to the equivalent of about 6 hydrogen atoms per cubic meter.
This is the part that is the dumbest thing I think I've ever heard anyone ever say about the universe. The geometry of the universe can be determined by the galaxies in it, and if there were more or less galaxies to the point where
If on average that was just one more hydrogen atom, the universe would have been more spherically curved. If there were just one less, the curvature would be hyperbolic geometry.
Really? Really? You realize, dumbass, that the moment... Yes, Derek, you're a dumbass. Just imagine for 2 seconds, you fast forward time to the point where the universe has spread out so much that the density becomes less than 7 hydrogen atoms per cubic meter. Guess what that means? Nothing! It means that you should have said that in the future it will be less, so therefore it will definitely turn into hyperbolic. But you didn't say that! Means you're not fully thinking it through, are you, Derek? The density of the universe doesn't mean shit. We could have 1/10 this amount of stuff in the universe, and we would have 1 hydrogen atom per cubic meter of total mass, energy, density of the whole universe. And we would still have a flat universe. You know why? I mean, besides the great attractor that's totally guiding stuff towards itself in a curved arc, which is interesting that it's curved. The entire universe needs to have something affecting. Literally, every time that you talked about curved geometry, you talk about a star or a planet, which is an object affecting the space-time curvature itself. The universe is a big freaking cloud, possibly with gaps in it, and the entire filament, which we are in, heading towards the super large... You don't mention that in this video. I don't know when you mentioned that. How old is this video? 18 hours ago! Wow! I get so pissed off at this shit.
And so far, we're not entirely sure why the universe has the mass energy density it has.
You literally realize, just fast forward time a little bit more, because you know that the universe is all, I would say, attenuating or spreading out like a bath bomb in the water. It's all spreading out, and guess what? It's going to stay flat no matter what you do to that, how far you stretch that, how far you spread it out. It's going to stay flat. You know why? Because you would have to basically have a concentrated mass, but you don't. There's a concentrated mass and the great attractor, and ironically, the great attractor is not pulling everything in a straight line towards it. It's a curved line towards it, which you'd have to watch another video to look at the great attractor and find out about that. But you already talked about it in the previous video. This is a recent yesterday's video. Yes, yesterday's video. I was awake when you posted this video. No, I wasn't. Wait, was I? I don't think I. What time is it? It's the 20th. It's not. It's 10 o'clock. I've been awake since 4 p.m. It's 10 a.m. So 4 to 4 is 12. 12 to 10 is another 10 hours, so that's 22 hours. I've been awake this whole time that you've had this video up. You have made videos about the Great Attractor. I'm pretty sure you have. Or that Space-Time guy definitely did. Veritasium, I swear. Did you make a video about the Great Attractor? Do you remember what that is? How we're moving towards it? Which is crazy. But of course, do you know why it's a curve that we're moving through? Towards the Great Attractor and not this weird wibbly wobbly? The whole thing is all moving in a basic amount of flow. The object of the Great Attractor itself is moving in its own curved motion through space. So that says nothing about the curvature of the space itself. In fact, the fact that there is a curve that we're moving through, and it seems to be correct that there is exactly pretty much straight universe. Yeah, that's because you can't influence the universe to cause a curve just because you have 7. Do you realize? Look at your dumbass self and the galaxy that you created.
Which is 0.0007 plus minus 0.0019. So that's basically 0 within the margin of error. So we're fairly certain that the universe we live in is flat.
Uh-huh.
But living in a flat universe would be remarkably serendipitous. Right now, the average mass energy density comes down to the equivalent of about 6 hydrogen atoms per cubic meter.
Shut the fuck up, you absolute idiot. You complete buffoon. What is this graphic? How big is a fucking hydrogen atom, you dork? How big is a goddamn hydrogen atom? How big is it? Nanometers. Hydrogen fucking tiny. It's a goddamn atom, for crying out loud. The density, okay, 7 per cubic meter? How many dots are on the screen right now? 3-dimensional space, it would look like that. You're right, but how many dots are on the screen? There are 6 dots on the screen.
If on average that was just one more hydrogen atom, the universe would have been more spherically curved. If there were
No. You pissed me off, Derek. Mr. Veritasium. Because 7 hydrogen atoms in a cubic meter? Let's take a poll.
The van der Waals radius of hydrogen is 120 picometers.
Picometers! What the fuck is that?
One meter is 1 times 10 to the 12 picometers.
So bitch ass God damn it! A lot of zeros. Okay, look, the energy density of the universe is like 7 out of 1 with a bunch of zeros. 7 out of 1 and a bunch of zeros. Cubed. Are you stupid? Derek, are you actually retarded? That's not fair. That's just not fair. It's not accurate, and I am retarded. You have to understand that. I am slow. This is me being slow. My brain is slow. Are you slower than me? Because seriously though, freaking 100 picometers? A hydrogen atom is 1/1000th the size of a meter. Okay. We got 7 of those in a cubic meter. Okay? So if you go to the full size of that, it's 1,000,000,000 times 1,000,000,000 times 1,000,000,000. Okay? And there are 7 inside of that number. 1,000,000,000 cubed. It's like 3 times the number of zeros. Basically, nothing. We have nothing in the universe compared to the full, the complete density of the whole. It's a lot of empty space, is what I'm trying to say. No, I get this pissed off. I say these words because it's so frustrating hearing you say this shit. Your diagram of
Average mass energy density comes down to the equivalent of about 6 hydrogen atoms per cubic meter.
6 hydrogen atoms per cubic meter is billion, okay, of a meter, whatever. Okay, that's how that pans out. And there are 6 or 7? Did he say 6 all this time? Whatever.
But living in a flat universe seems to be remarkably serendipitous. Right now, the average mass energy density comes down to the equivalent of about 6 hydrogen atoms per cubic meter.
Okay, he said 6. I said 7. I don't know how I got 7 out of that. Shut up. I can admit when I'm wrong. Your fucking diagram is bullshit. This is not the area of freaking. In order to show 6 dots in a cubic meter, you have to show like a zoom in of a space of the cube and be like, they're in this space. It's tiny. The area of effect, the amount of influence that you have as a universe on your area of space is minuscule. If there were 7, it would would crunch. It would just crunch into a circle. No, it would not, Derek. How goddamn dare whoever made the paper that you're quoting, whoever fact checked you, whoever made the script, any of you on the line saying this, and you yourself as a scientist, you saying this, you're dumb. A cubic meter is to a hydrogen atom as a billion. Okay? I said it before, I'm saying it again because it's important to get this through your head. It's a billion. If you were to slice it up and put it on a straight line, it's a billion. That's how that works. And there are 6 inside of that billion. That is the mass density of the universe. That is what that is. There's a number that you can use for this mass density. It's a billion quadrillion. Or a sextillion. In other words, it's 6 out of 6. It's ironic. It's 6 out of 6,000,000,000. Is that right? Is that not the number? Ten to the 30. It's 10 to the 30 zeros. And then you have just the number 6 in that 10 to the 30 zeros. I don't need to be right about everything, but it's 10 to the 30 zeros. That's what billion cubed is. If it was 5, it wouldn't be hyper... What the fuck did he say?
If on average that was just one more hydrogen atom, the universe would have been more spherically curved.
Okay. No. The universe would be more spherically curved. In what universe would a universe of just one more part per sextillion? Hexa? 10 to the 30. In what universe is 10 to the 30 gonna give a damn whether it's 6, 5, or 7? That's why I get the number 7.
If there were just one less, the curvature would be hyperbolic geometry.
No. Just no. It's funny because when you reverse time, it was more dense. It was way more dense. So that's why it's possible that the entire space-time was a sphere, and then it's expanding out into a hyperbolic, but right now we're flat. Do you realize what you're saying, Derek? Because earlier on, everything was dense, right? So we have the density of the universe be a lot more than 6 per cubic meter. 6 per 3 to the 10, or 10 to the 30. We have a lot more than that. Okay? It's a lot more dense than that. It's more like when the universe was forming with the Big Bang and everything, you could have said that back then it was maybe 10 to the 20th out of 10 to the 30. quadrillion inside of a cubic meter. Quadrillion hydrogen atoms per cubic meter. That's what it was at the freaking beginning. If you rewind time according to the theories that they have. Which I'm not even fully Dude, Hank Green, you said it correctly that the universe apparently before this video, Hank Green said on a short that the universe expanded all at once from everywhere. It happened instantaneously all at once everywhere. There was one instance of like nothing or static, and then flat and not even moving, and then suddenly, boom, everything all started happening everywhere. That's what the Big Bang is theorized to be currently. Your video is regurgitated, because I swear I've heard this video before, and this is a new video. It's not even a different channel. It's still Veritasium. He's saying the same stuff. But it's like, no, you can't keep saying the same stuff. Update your facts. Get it straight. Get it correct. Stop saying about these false freaking things that are false. You can't keep saying it. It's not true anymore. We understand better how the universe works. We can't keep saying about this the same way. It's not okay. As scientists, we can't accept this blatant disregard for facts. That's what Derek has done. I don't know I don't know his last name. Very few people will know Derek by anything other than Veritasium or Derek. The dude got multiple things wrong in this video, and the guy he was working with in the video got multiple things wrong. It's upsetting. It is very freaking upsetting. Space-time doesn't curve. But we need an entire field of people talking about the electromagnetic fields of stuff that is out there in the universe, which is basically how light travels through the universe, to understand how it definitely is everywhere, and it is the thing that makes gravity happen. Light? No, electromagnetic field, which is everywhere. Light is the wiggle of the field. Electrons are not the electromagnetic field. The electrons excite the electromagnetic field around them. The aura is a practically invisible, in fact, completely invisible influence of the electromagnetic field, to the point where they are still having an influence. It's not light that's connecting. You realize it's not light connecting electrons to protons and neutrons with the atom. You know that, right? You understand that there is the electromagnetic spectrum. You might say it as light, and it might be the same as light, but when you come down to it, the wiggles of light are wiggles of the electromagnetic field. The field itself is a majoritively invisible, constant, everywhere fabric of the universe, spanning every inch, square, picometer, or what's the Planck scale of the universe. It's all over the place, the electromagnetic field. And Higgs field. And if you wanted to explain gravity, you're not going to explain it in a particle, you're going to explain it in a field. And some kind of part on the spectrum of energies. It's not going to be a freaking particle anymore. Unless, if you do find out that what the fuck is happening? with my notifications right now. It's pissing me off. What the fuck is that? Fuck off. You got me distracted from being pissed off at Derek to being pissed off at you. Not just Derek, but all science communicators everywhere who's talking about this stuff. Who in their right mind said that 6 out of 10 to the 30 is enough to change the way the universe is holding? It's not. What the fuck is happening? Of course, when they said, here's the thing. The guy owns a lot of group chats. Fuck you. I turned off the notifications. Listen. Space-time doesn't curve. Okay? The universe being as thick as goddamn empty ocean with a couple little dots, it wouldn't be more curving, it wouldn't be more hyperbolic just because of the stuff in it being more or less. In order for stuff to start affecting space-time, you realize the mass has to be pretty much 10 to the 20 in every 10 to the 30. 1/3 of the stuff in the universe has to be full. And what is it? It's 6 out of 10 to the 30. Six hydrogen atoms out of a meter cubed. It's a huge difference. Literally, when you go forward in time, the universe will literally be less dense. You go forward in time 100,000 years or 1,000,000 years, billion years, it's going to be less dense. And guess what? Does that mean the universe is going to start becoming hyperbolic? No, it won't. It will still be flat. And that's my postulate. That's what I'm saying. You got it wrong, and you're dumb, and I'm tired of it. It's upsetting. It's not acceptable. I can't believe you're stating this stuff. I got upset at you at first for the Euclid stuff, because all the dude said, if two lines slightly less than parallel continuing, they're going to meet eventually. Duh. He's just explaining a flat, on paper, just a triangle. As if on paper, it's just a triangle. Or a flat, any flat continuous surface, it's just a triangle. Like a sheet of metal or whatever else, or two train tracks. Like, you got to make sure those are pretty much parallel or you're going to be screwed. Right? The train's going to be messed up. So you got to make sure they're parallel. But you're going around a planet, or you're going up a hill or whatever, So sometimes the lengths of those train tracks still need to be parallel, but they need to be different lengths. Just because they're going up and down a hill and stuff. Lord help you if you're turning while going up and down a hill. When you're going up and down a hill, you want to be as flat as possible. Otherwise, the one side is going to be a lot shorter than the other. And stuff. As we see on Railroads Online, the truth of that and how that works. Because duh. Dude's just talking about train tracks. Dude's just talking about a triangle. His first axioms were about straight lines, wobbly lines, and then I don't care about your party city. He's just talking. Euclid was just talking about a freaking triangle of some angle. That it's like you talk about the outside of the angle. You could be instead also talking about a circle, and the angle is a fragment of a circle. But the general gist of it is that the two lines slightly less. They're not straight, they're less by a little bit. It doesn't matter how much, just by less. General term, less. And then you go, but instead of saying that, you say something else. You say something about two parallel lines, blah, 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 blah. And I'm like, you convoluted the shit out of that.
A straight line is a line that lies evenly within the points on itself, and then so on and so forth. He's got 23 definitions, then he's got the 5 postulates.
The first 4 are simple. 1, if you have 2 points, you can draw a straight line between them. 2, if you have a straight line, you can extend it indefinitely. 3, given a center and a radius, you can draw a circle. And the 4th is that all right angles are equal to each other.
So he talks about lines. Lines can be longer. You could make a circle with like a point and like a string, and you go around and the string doesn't change its length. You make a circle. If it changes its length, you make an egg shape or something.
Postulate 5 gets the big guns.
Which is that if a straight line falling on 2 straight lines makes the interior angles on the same side less than 2 right angles, the 2 straight lines, if produced indefinitely, meet on that side, on which are the angles less than the 2 right angles.
He's talking about a triangle. He talked about a right angle thing. He talked about a circular thing. He talked about a triangular thing. That's all he did. And you went and you said, "Oh, this is this big question." 2,000 years, people are like, "Do we even work with this guy? Do we even prove this? Do we prove it by contradiction? Do we do this other stuff?" 2,000 years, scientists, smart people. They couldn't figure out he's just talking about a goddamn triangle. The basic concept of a triangle. He's not even hyperbolic. He's not circular at all in this. He's just talking. Of course they meet on the sides that are less than the right angle. Yeah. You mean the stuff that is all pointing towards each other? Those 2 bits? These 2? They're gonna meet on this part here? Yeah, they freaking are. That's called a triangle, bitch. It's a simple geometry thing. Basic squares, basic circles, basic triangles. That's all he said. That's all he fucking said. I sound like a crazy person. I don't care. That's all he goddamn said. Because it's this upsetting that you got it this wrong. That's how much upset I am. I could make all of this and say it in a short. And I will try to do a synopsis where it's like, no, it's this! And then I'll jump to the next thing. I'll try to say every part, I will try saying in 20 seconds. So you have there are three different things you got wrong, maybe? I'll say it in 15 seconds. I don't know. I'll try to figure it out. Toodles! Thanks for hanging out with me. This is Science Me playlist. Go ahead and check that out, where I talk about all sorts of things science, like how heavier objects can float more than lighter objects. That's true. Bet you $1 million that there are cases in which that is true. You'd be dumb to take that bet. I would totally win that. I proved it in a different video. It's called buoyancy. One is denser than water and the other one's less. But it just happens to be so big that it don't matter. It still floats more than water. Duh. Okay, I spoiled it, but there's more to it than that I mentioned, and you can look up the video. It's in the playlist. Or other stuff, like time doesn't dilate. That's an important fact. Gonna have to figure this out eventually. I'm sorry to tell you this, but time travel is also a thing that you can't just do by bending space-time. The whole idea of bending space-time is absolute nonsense. It will never actually work. If you do the stuff that you think is going to do to bend space-time by making a big gravitational well or forcing someone to go super fast, they're not going to go into the future really suddenly or whatever. Or they're not going to end up being able to twist space-time in a big enough bend that it loops on itself like a Mobius strip or whatever and goes back in time or jumps forward in time. That's not a physics valid thing. It will never happen. But unfortunately, I'm correct. What does that mean? It means that you can't go through space-time and go backwards and forwards by using the supposed theory of bending space-time. It doesn't work like that. So if space-time doesn't work like that, do you have a way that we could maybe go through space? And my answer to that is, sadly, no. Unfortunately, no. Are you saying there's no way to go through space-time? My idea of space-time right now, as it stands, is that everything is happening now. It's iterating on top of itself, and that's why time seems to move forward. But everything is just happening now. The past doesn't exist anymore. It happened. The remnants and the echoes are still there, and the shadows are still there, and the distant light that is still hitting us from billions of years ago is still coming to us because it takes time to get there, but it's all processed all instantaneously at the same time. Our ability to witness it all isn't caught up, but it is all happening all at once. The frame rate is all the same everywhere. Your clocks are messed up. I beat determinism with hair. I remember one guy said that he thought that English wasn't my first language. I say to some people English is my third language, thank you very much. And if you know anything about how the brain works and languages work, you would understand that. But if you don't, I don't know what to tell you. The first language is just conceptual, by the way. That's a hint. No one speaks a language when they begin. I mean, you're even in the womb, you're hearing language. You understand concept of like yay and and they like music. Babies like music. That has nothing to do with language, but it is a concept in their head. And they get it. There's no words associated, but it's a concept. Memories might not even be forming, which is fascinating. But there are concepts happening in your head. And before that, or in between that and actual language, is there's another language that you end up finding out about, which is like, wait, no, that doesn't make any sense. You should have there's just concepts of items, and then there's actual, no, it's called abstracts. There's concepts, there's abstracts, and then there's actual language. These people, and this is why I mention language, these people have the nerve to go and say, well, I don't even like the idea of definitions. I'll just tell you the relations between things. And so you say it's a dot and it has no more parts. It's just a dot. You're talking about atoms. It cannot be devised anymore. It is just a point particle at that point. And there's a reason for that. There's a reason why he talks about a point being indivisible, because you're not talking about a square with dimensions. You're not talking about a circle with dimensions. You're talking about a dot on a piece of paper that represents a zero size individual just somewhere on the paper that is a coordinate. It is not anything other than that coordinate. It is zero mass. And it might be microns big, but who cares? It's still basically otherwise considered to be just a point. As what his definitions. And the line can be squiggly and whatever else. And something. And it's like words, then you got to describe them by using words. Words as in syntax, or a concept, or a thing, which is a word. But if you forget about the fact that you're using descriptors on top of descriptors on what's a word? A word is usually either a written or an oral construct of what we would otherwise call language. So yeah, the first language you learn is abstracts. The second is constructs, concepts. The abstract is a concept with very little definition whatsoever, very little anything else whatsoever. It's just maybe the relation to other things. It may be just harmonics. It may just be simple things. And then after that, you get into the concepts of stuff, where things have more structures, things have more actual like ideas. Like you can understand what a circle is versus a square and all of that. You don't need words for that, but you understand that it is relative to your finger a lot more than it is relative to the angle that your knuckle is able to bend mostly at. It seems to be mostly square, and that is associative of squares, even though your knuckles may bulge a little bit because they're freaking round, muscly things and stuff. And the line is basically your mouth. Your mouth's a line. Your nose is a triangle. Your eyes are circles. Your big head is an oval. Your teeth are squares. Ideas. Abstracts. The reason why abstracts is a language in and of itself is because it doesn't have any sensory cues whatsoever. It's an abstract. There is no visual. There's no audio. There's no tactile of touch or anything. Okay, there might be audio, but there's no visual. There's no like sense of like what's in front of you, except for maybe you do in the womb you see like this glowing, like when you see the inside of your eyeballs, you see that. Like if you were to shine a flashlight towards a baby, it'd be like, ah! Suddenly brightness everywhere. Like when you shine a light at the inside of your eyeballs, you can witness that. It's orange. And you can tell the difference between it being bright out and being dark out. It's like when you're wearing a shirt and when you lift your shirt up. It's like, hello! There's more light coming at me. Yay! What is this? It's an abstract thought. And you have the concepts of it, like you know how it's like, come here. It's like, okay, if come here means I move towards person, then I move towards person. Or if this is me, and if that is you, then me towards you is coming. So I'm coming to you. I come to you. I'm here now. Yay. And all of this is done without words. You don't even learn or use words until later. It's ironic that it would be interesting to know, can language form before memory? Does memory happen first, then language? The interesting thing about that is you can have a lot of processes that's like that can be inside of the random access memory of your brain, which is the active, still present mind processing, and it's when the long-term processing kicks in that you actually get, maybe, I don't know. It's a very good question. Excellent question. I love that. When does the brain start having proper language? Because like the data and all of that stuff, it's like you associate stuff and you know stuff more than you start saying stuff. So I would say that memory happens way before language. Memory happens way before language. You might, the thing is, again, there might be a subconscious memory and there might be then the conscious memory of you actually knowing what the hell pi is. It's that delicious thing that they put pumpkins in. It doesn't make any sense because it doesn't taste good as a pumpkin, but then when they put it into pie, it's like not even looking like pumpkin, because pumpkin is like that. And then this is looking like this. Probably because of all the other stuff they put in it, like the marmalade. And you put that in it, and it's like, this is pumpkin pie. I say that because I have a pumpkin pie slice in my fridge that I need to eat, and I'm hungry for it right now. You can use definitions and then define what a word is. And if you couldn't say stuff with audible words or written words, and you had to use something like, I don't know, sign language or something, you would still be able to have the idea of language. You would just have concepts be expressed through sign language. And language would still exist, it's just words wouldn't exactly the same. It's like words with sign language is weird, but it's a thing. I don't know. Time doesn't dilate, space doesn't curve, and the universe would not become more curved or more flat or more flat. It wouldn't become hyperbolic or circular if it had one more hydrogen atom in it. Your diagram sucks.
What the hell is he talking about? That's a postulate? Like, all of these are, half of a sentence, and they're all blatantly obvious. And then comes 5 out of left field, and it's like an entire paragraph. What is he doing?
He's talking about a triangle. I'm done talking about this because his video is only 30 minutes long, and my explanation of all of this stuff is 3 times as long. Because holy crap.
Size. Now, since you get all this extra space, so you can fit more and more triangles. So they appear smaller, but they are actually the same size. Now, since the hyperbolic plane is infinite, you can keep adding triangles forever, and they all need to fit on the disk. So as you get closer to the edge, the triangles will appear smaller and smaller and smaller, infinitely smaller, never ending, and you can never quite reach the edge.
This happens because the idea of that shape is not an actual circle, but it's a sphere that is projected onto a circle, and you're looking at it from like way above or something. I hunger. I have to go to sleep or something, or drink some water. I don't know, whatever. Toodles. I don't care. You got it wrong, Derek. I am sorry I said the R word. That was uncalled for. But are you slow? Genuinely. Like, people with autism, there's a little bit of slow. And the thing is, it's not even that they're slow. It's that they have so much going on in their head that the process of any one process function in their head is slowed down by all the other stuff that they're trying to think of. So really, when someone says retard, they're actually talking about someone incredibly intelligent. It's just hard to get a beat on what the hell they're talking about. Yeah, it depends on if your head empty or head full. Still, the phrasing of the R word is head empty. And I'm sorry. But if anything else, it displays exactly how far you can put a point. You can make a point and you can make an argument, you can make a debate without resorting to insults. When it comes down to insults, then it's like, okay, you're going into the irrational side. No one's going to care what you think because you went too far. You bet $10,000 that the car wouldn't fly faster than the wind. And he took that bet because he's an idiot. And you know it. Once you move with the wind, okay, you're already postulating the car can move as fast as the wind, because its propeller, giant as it is, works like a sail. But unlike a sail, it also pulls air from in front of the car, behind the car, so that you're pulling yourself forward as well. So you're being pushed and you're pulling yourself forward, meaning totally your speed should be at maximum faster than the wind, likely not twice the speed of the wind. Likely not twice the speed of the wind. That's my upper bounds for that nonsense. But the fact that it would go faster than the wind is a no-brainer that anyone who is a scientist should have understood, because there are two powers at work. The first is the ground is translating into the propellers, turning and pulling the air forward, and it's also being pushed by the wind. Once it goes fast enough, it can go as fast as the wind. And once the propellers start moving and pulling it forward, then it starts moving faster than the wind. That's a no-brainer. You should have never made... I mean, making that bet just proves, sure, yeah, okay, and it's proven. And we're willing to put our money where our mouth is. Sure, whatever, fine. But he was stupid if he actually didn't understand it in the first place. It's like asking someone on the street, I'm sorry, dude, scientist who didn't get it right. If you're willing to look stupid for the sake of a silly bit of a video and to prove a point to science so that people actually believe it, because otherwise you just gave away $10,000 for nothing. But it's actually true. But you should never have even made that bet in the first place. You should have known what you were talking about. And I do. I already guessed without even watching the full video. It's like, wait. No, there are two forces at work here, so it should add up. Why would it not add up? I don't know. There's this whole lot of other stuff I can talk about. I'm not gonna. This is my second video today. Toodles. Check out my Science Me playlist, where I scream at people about all sorts of things science. Because I'm passionate about it. I love you guys. And I want you to be